Okay, so here we're going to look at factors affecting electrical resistance, the factors that affect resistance. So basically, there are five main factors that affect resistance, that affects the resistance of any conductor, of any resistor. So the five main factors are the length of the conductor, the area of the conductor, the temperature, the cross-sectional area, and the resistivity. The resistivity depends on the nature of the material, right? So these are the five main factors that affect the resistance of a conductor. Number one is the length of the conductor. Secondly, we have the area of the conductor. Thirdly, we have the temperature. Then number four, we have the cross-sectional area. Then we have the resistivity that depends on the nature of the material. So these five main factors that affect the resistance of the conductor, you must know. It's very important. And there is a formula that connects some of these parameters. So the formula is this. It's giving us resistance, which is R, is equal to resistivity times length over area, right? Where your arrow, which is this arrow, is equal to the resistance. Your resistivity, this rule, resistivity is equal to the resistivity. L is equal to the length, and your A is the cross-sectional area, right? So this is the formula that connects some of these parameters. So one thing that you should know here, very important, is that the resistance of a conductor, which is R, is directly proportional to the length, and it is vividly well shown here. R is equal to resistivity times length all over area. So your resistance is directly proportional to what? The length of the conductor. What that tells you is that the higher the length of the conductor, the higher the resistance. The lower the length of the conductor, the lower the resistance, right? So this is very important. Also, you should know that resistance is inversely proportional to what? Area. What does that tell you? That the lower the area, the higher the resistance. The higher the area, the lower the resistance. So they are inversely proportional to each other. If one increases, if the area increases, resistance is going to decrease. If area decreases, resistance will what? Will increase. As regards to length, they are directly proportional to each other, right? As the length increases, resistance will increase. As length decreases, resistance will decrease. So these two things, you must take note of them, right? Very important. Resistance is directly proportional to the length of the conductor, and the resistance is inversely proportional to the area of the conductor. Another important thing that you should know here is that resistance as well is directly proportional to temperature. This is very important. What it tells you is that as the temperature increases, resistance will also increase. As temperature decreases, resistance will decrease, right? So this formula is very important. Resistance is equal to resistivity times length all over what? Area. So if we are to calculate for resistivity, we have that R, which is resistance, is equal to resistivity times length all over what? Area. If we are to look for resistivity, this is the same thing as R all over 1. I can cross multiply, right? So this will be resistivity times length times 1, which will give you resistivity. That will give you resistivity times length. That's this times this will still give you this, right? Resistivity length times 1 will give you resistivity length is equal to R times A will give you what? RA. So resistivity, if I want to make resistivity the subject of the formula, I would divide both sides of the equation by the coefficient of resistivity, which is L. So this is divided by L divided by L. L will cancel L. So resistivity from there will be equal to RA over what? L. So this formula is very important. Resistivity is equal to RA all over length. Resistance is equal to resistance length all over what? Area. So this is very important. This is very important, right? So let's look at some questions. The first question I have here is, which of the following factors does not affect the resistance of a wire? Which of the following factors does not affect the resistance of a wire? So we have looked at the factors that affect resistance, right? Length affects it, material, the nature of the material affects it, temperature affects it, but color does not affect it. So this is the right answer. It's one of the factors that does not affect the resistance of a wire. So the five main factors that affect it are the length of the conductor, area of the conductor, temperature, cross-sectional area, and the resistivity, which depends on the nature of the material, right? So length affects it, material affects it, right? That's the nature of the material, which is the resistivity. Then temperature affects it, but color does not affect it, right? So the answer is color. The resistance of a wire is directly proportional to its A, cross-sectional area, B, length, C, voltage, D, current. So to know this, we just have to write out the formula that resistance is equal to resistivity times length all over area, right? So from what I've mentioned before, the resistance of a conductor is directly proportional to what its length. So resistance is directly proportional to its length, to the length of the conductor. So this is well shown here in this formula. So the resistance of a wire is directly proportional to its length. So B is the correct answer here. It is directly proportional to what? The length of the conductor. And resistance is inversely proportional to what? The area of the conductor. So it is well shown in this formula. Let's look at the next question that we have. If the cross-sectional area of a wire is doubled, its resistance will if the cross-sectional area of a wire is doubled, its resistance will. So this is kind of more complex, but it's not very complex. So let's unravel it. We have that resistance from the formula is equal to resistivity times length all over area, right? And like what I said, that resistance is inversely proportional to what? The area. What that tells you is that as the area increases, resistance will decrease because they are inversely proportional, right? They are inversely proportional. As the area increases, resistance decreases. As the area decreases, resistance increases, right? So if the cross-sectional area of a wire is doubled, if it is doubled, doubled means times 2, right? its resistance will not be what? 1 all over 2, which means that 1 over 2 is half, right? Which means that it will half. So the correct answer is what? Its resistance will half. It will half. So this is very important. This is very important. If the cross-sectional area of a wire is doubled, doubled means times 2. So if the area, let's say for example, the area is 1, right? If the area is 1, 1 times 2 will give us what? 2. So the resistance will now be what? 1 all over 2, which is half of what? The original resistance, right? So this is very important. So if the cross-sectional area of a wire is doubled, its resistance will half, right? So very important. Let's look at the next question. The unit of resistivity is so from the formula we have that resistance is equal to resistivity times length all over what? Area. If we want to make resistivity the subject of the formula, we can say resistance all over 1 is still the same thing as resistance, right? So we can now cross multiply. Resistivity length times 1 will give us resistivity length, right? Is equal to R times A will give us RA. So to make resistivity the subject of the formula, I will divide both sides by the coefficient of resistivity, which is length. So this is divided by L divided by L. L will cancel out L. My resistivity will be equal to RA all over what? The length. So this is the formula for resistivity. But the question is, the unit of resistivity is, so what do you think is the unit? The unit of resistance is what? Ohms, right? So that's ohm times the unit of area is meter square, right? Over the unit for length is what? Meters. So the unit for resistivity will be equal to ohm times meter square. Meter square means meters times what? Meters. Area is what? Length times length, right? Length times breadth or length, all the same, right? So that will be meters times meters. That's your m square over meters. So m will cancel out m. So what I have is what? Resistivity is equal to what? Ohm meter. Ohm meter. So the unit of resistivity is what? Ohm meter. So the correct answer to this question is what? Option B, ohm meter. So let's look at the last question that we have here, and that is a calculation question, right? So the question is, a copper wire has a resistivity of 1.68 times 10 raised to the power of minus 8 ohm meter, a length of 2 meters, and cross-sectional area of 0.5 times 10 raised to the power of minus 6 meters squared. What is its resistance? Right? So a copper wire has a resistivity of 1.68 times 10 raised to the power of minus 8 ohm meter. So what does that tell us? That the resistivity is equal to 1.68 times 10 raised to the power of minus 8 ohm meters, right? A length of 2 meters. So the length of the copper wire is what? Is 2 meters. And cross-sectional area of 0.5 times 10 raised to the power of minus 6 meters squared. So the cross-sectional area is equal to 0.5 times 10 raised to the power of minus 6 meters squared. What is its resistance? So what we are looking for is the resistance of the copper wire, right? So the formula that connects these four parameters is resistance is equal to what? Resistivity times length all over what? Area. So this formula, like I said before, is very important. So we are asked to look for what? The resistance of the copper wire. So the resistance will be equal to, the resistivity is 1.68 times 10 raised to the power of minus 8, right? 1.68 times 10 raised to the power of minus 8, right? Times the length. The length is what? 2 meters times 2 divided by the what? The cross-sectional area. The cross-sectional area is 0.5 times 10 raised to the power of minus what? 6. 0.5 times 10 raised to the power of what? Minus 6. So having done that, the next thing I will do, my resistance will now be equal to, so I will use this 1.68 to multiply these two, right? That's the next thing I will do. So 1.68 times 2, that will be equal to 3.36, right? So that will be equal to 3.36 times 10 raised to the power of minus 8 over 0.5 times 10 raised to the power of 1 minus 6. 1.68 times 2 will give us what? This 3.36, right? Again, how we got this 3.36 is 1.68 times 2, right? So having done that, my resistance will now be equal to, the next thing I will do is to use this 3.36 to divide this 0.5, right? So 3.36 divided by what? 0.5 divided by 0.5, that will be equal to 6.72, right? So that will be 6.72 times 10 raised to the power of minus 8, which is this 10 raised to the power of minus 8. When this 10 raised to the power of minus 6 comes up, it becomes plus, right? It becomes plus. So times 10 raised to the power of what? Plus 6. When this minus 6 comes up, it becomes what? Plus 6, right? So that's the rule of indices. So my resistance will be equal to 6.72 times. So since the base numbers here are the same, the root number are the same, 10, 10, 10 raised to the power of minus 8 times 10 raised to the power of minus times 10 raised to the power of plus 6. So since the base number are the same, I will take one of them. So that will be times 10 raised to the power of minus 8, and then I'll add the powers, right? Plus 6. This is the rule in indices, right? Since it is multiplication that separates them, I will add the powers. So that's minus 8 plus 6. That's how we got this minus 8 plus 6. We are taking one of these 10 because the root numbers are the same, right? 10 raised to the power of minus 8, 10 raised to the power of minus 6. I will take one of them and then I will add the powers. That's minus 8 plus 6. So my resistance will be equal to 6.72 times 10 raised to the power of what? Minus 8 plus 6 will give us what? Minus 2, right? Will give us minus 2. So my resistance will be equal to the minus 2. The power of minus 2 means 0.0, right? 0.0. It means that there are two zeros. So 0.0672. 0.0672, right? So this is our answer, 0.0672 ohms, right? This is our answer. So the correct answer to this question is option A, right? 0.67 ohm. So this is approximately the same thing as 0.067 ohm. So that's our answer. All right. So with this, we come to the end of this lesson. So just a quick recap. We've looked at the factors affecting electrical resistance, right? And we said that the 5 main factors that affect resistance of a conductor are the length of the conductor, the area of the conductor, the temperature, the cross-sectional area, and the resistivity, which depends on the nature of the material, right? And we looked at the formula that connects these parameters, that resistance is equal to resistivity times length all over what? Area. When we make resistivity the subject of the formula, resistivity will be equal to resistance times area all over what? Length. From this formula, we know that resistance is directly proportional to length and resistance is inversely proportional to what? The area. And also resistance is directly proportional to temperature, and you know what all this means and the application. So that will be all for today. Thank you very much for listening.